And that's a good point. Some of you guys have had anatomy and physiology before. Some of you I read on your cards were in Project Lead the Way, which is awesome. And that means you've covered a lot of this stuff already. Okay? So we are going to be going relatively quickly through this first little bit of stuff. But if this isn't review for you, if you haven't had anatomy and physiology before, if all of this is foreign to you and you need some extra help, feel free to come talk with me, okay? You can always stop me while we're lecturing as well, okay? I want this to be interactive and us to talk things out together, okay? All right, so we ended up, class, on Wednesday talking very quickly about what the word anatomy means. Okay, so anatomy is the structure. Okay, how everything fits together. And then today we'll start on what is physiology. And guys, I realize that there's a little chunk of my screen that's kind of dark. I don't know why that is. I'll try to fix it before Monday. So for right now, just disregard it. Pay no attention to it. It's not there. Okay, so physiology. Physiology is the function. And that's what we're going to be spending a lot of time in this class talking about. So anatomy will be covered a lot in lab. Physiology will be covered a lot in here, okay? So physiology is the function, but physiology and anatomy are inseparable. They work together. So we say that what a structure can do depends on its specific form. So they have a complementarity of structure and function. Okay, so complementarity is how structure and function are related. Okay, so a way to remember this is the shape of the glob determines the job. Okay, so the shape that something has determines what it can do. For example, I have here a white blood cell and a red blood cell. Okay, we'll just call him a white blood cell for now. Later, we'll give him lots of different names because there's lots of different white blood cells. But in general, what is a white blood cell's function? What does he do? Fight diseases. So he goes out, he finds bad things, and he eats them up. Okay? So if you look at the structure of this white blood cell, he has lots of these little extensions coming off. Okay? So he has extensions so he can go grab bad things and get them inside of him and then chew them up. Okay? So structure matches function. On the other hand, this guy is a red blood cell. What's the function of a red blood cell? To carry oxygen. I heard a couple people say it. Okay, so he transports oxygen into the body, and he transports wastes outside of the body. Okay, he gets rid of it. Okay, so he has to be able to pick up oxygen, get it inside of him, and then get carbon dioxide outside of him. Okay, but instead of grabbing things like the white blood cell does with his big arms, because bacteria and things are really big, the oxygen is transported across the membrane because it can diffuse, it's small. So, the red blood cell has a shape of a biconcave shape. You can kind of see it up here. It dips in the top, it dips in the bottom. It's like a donut with a hole still in the middle of it. Okay? But that increases his surface area. There's a whole lot of plasma membrane there that allows a lot of gases to diffuse across them very, very easily. Okay? So, two blood cells, two different functions to eat big things, to let little things diffuse across, and they have two different structures. Big arms to grab things, lots of plasma membrane to let things diffuse. Okay? So structure and function match. You'll see that a lot as we go throughout this course. It's almost, one might say, as if somebody designed them to do their job. Imagine that. All right, so structure gives us the function. The shape of the glob determines the job. Okay? Any questions? Okay. I hate that my screen is half dark, but it's okay. So the human body is organized in a hierarchical system. So we can take you apart little by little, and we're going to find the very smallest thing that makes you up. Okay? And then we'll put those little small things back together and build an entire organism. Okay? So let's break you all the way down. You are into the smallest pieces that we can break you into. Those smallest pieces are called atoms. So in our and you put several atoms together, what do you get? A molecule, so that's next. When we're talking about making living things are made out of cells. But before we make cells, our atoms or our molecules will join together to form organelles. Does anybody know what that organelle is in this picture? The mitochondria, right? He's the powerhouse, makes some ATP. Okay, so we have organelles. But there's lots of different organelles. We put a bunch of organelles together, what do we get? A cell. Okay? And the cell, if we're looking at this entire thing, is the smallest thing that's actually considered living. Okay, so the cell is the smallest one that's actually living. Okay, when we get a bunch of cells together, what do we call that? Tissue. And these cells are going to be doing similar things, so they make a tissue. Then when we take different tissues and put them together, we end up with an organ. Okay, so in this example, we took smooth muscle cells, we put them together, and we get some smooth muscle tissue. And then we put some smooth muscle tissue with some connective tissue and some epithelial tissue in the middle, and we end up with an organ called a blood vessel. Then we take a bunch of different organs and put them together, and what do you make? Organ system. So in this example, this may be a specific artery. We put that artery with all the other arteries, with all the veins, with all the capillary beds, and with the heart, and you end up with the cardiovascular system. That's what organ system. And then, once you get all the different organ systems together, you end up with an organism. Okay, so make sure you can put those in order, from the smallest to the largest, or from the largest to the smallest. Okay? All right, any questions with our hierarchical system of organizing an organism? And this is going to be the outline for the beginning of this class, okay, for the first part of the semester. We're going to start with biochemistry, which is on the atomic and molecular level. Then we'll start talking about cells themselves. So we'll talk about organelles and the cells that they make up and how they interact with each other. Then we'll get to tissues level. We'll talk about histology. Then we'll talk about our different organ systems, and that will take us through the rest of the class. Okay, so real quickly, we are going to do just an overview, get us introduced to all the different organ systems in the body. So if you look at your objectives, the things that you need to know about your organ system are a brief summary of what the organ system does, and a few of the important organs that live in that organ system. Okay, so brief function of the overview of the organ system, and a few of the main organs. Okay? So you'll find this in your book in Figure 1-3, and we're going to go through them really quickly here. Okay? So the first one that your book lists, and the first one that we'll talk about this semester, is the integument system, or the integumentary system. That's made up of your hair, your skin, your nails. What is a brief function of the integumentary system? Why do we have it? Protection, yeah. So, it protects us from what's outside. What else? Protection is a big thing. Okay? So it's going to protect bad things from getting in. It's going to protect water from getting out. It's also important for the production of vitamin D. Okay, so sit out in the sunshine, get you some vitamin D. Right, and there's a few other things that it does. It has lots of receptors, so it helps you interact with what's outside of you. And we'll get to that when we get to the integumentary system. Okay? The skeletal system is next. Some of its components are bones and joints. And what is a brief summary function of the skeletal system? Support. Okay? So your skeleton supports you, helps you stand up straight. It supports the organs underneath it. It also stores minerals. Okay? So calcium, phosphates, things like that are stored in your skeleton. Something else really important is made here. Red blood cells. Okay, so we also produce RBC. Okay? Alright, I see some discussion about the attendance sheet. Where is it right now? Over here. Who hasn't seen the attendance sheet? Right here? Okay, so pass it, make it get that direction. Okay. Questions about the integument and skeletal system? Okay. Next, muscular system and nervous system. Okay, when we get to the muscular system in this semester, we're going to speak primarily of skeletal muscles. Okay, so that's the component, those are the organs that make it up, are the skeletal muscles. And what's the purpose of the muscular system? What does it do? Helps you move. Okay? Helps you move. That one's pretty simple, right? We got that one. Okay? Next is the nervous system. And the components that are listed on the screen in your book are the brain, the spinal cord, and the nerves. So those are your major organs that you need to know for right now. Later we'll add things like receptors and things like that to the list. But we won't worry about that right now. Okay, what's the purpose of your nervous system? Okay, I heard communication. Okay, so your nervous system does communicate. It takes information from outside, sends it into a central processing area, so your central nervous system, your brain, your spinal cord, and then whatever your brain and spinal cord decides to do, it communicates that information out away from the central nervous system. So it is a very good communicator. And this communication that happens is very fast. So we're talking about fast communication. You'll be able to activate muscles, activate glands to do things. Really the control center of your body. Okay. Any questions on those two? Next two, the endocrine system and the cardiovascular system. All that we've talked about so far will be covered this first semester up to the endocrine system. So this will be the last one we cover this semester. The rest of those will be AP2. Okay, so the endocrine system is made up of glands that produce hormones. You'll see the ovary and testes that have a lot to do with our reproductive system. We'll get to it in the very end. But there's lots of other glands here as well. Okay, what's the purpose of the endocrine system? Secrete what? Okay, and why do we have hormones? Okay, he also regulates function. He's also a communicator. Okay. So he's also sending information from one place to another, telling something else what to do. except this time, hormones take longer to act. So instead of the fast communication we have with the nervous system, hormones are a slower form of communication. Because hormones have to travel through the blood or the lymph from one place to another. Okay, that's the endocrine system. Our next system is the cardiovascular system, which is made up of the heart and the blood vessels. What's the purpose or the function of our cardiovascular system? Transport blood. Okay, and what is transported in the blood? Okay, oxygen. What else? Carbon dioxide. Nutrients. And other waste. Okay. So the heart is going to be the driving force, that muscle behind pushing the blood throughout the body. Okay. Questions on those two? Our next two, the lymphatic system and the respiratory system. The lymphatic system contains your lymphatic vessels, your lymph nodes, the spleen, the thymus, and your bone marrow. What is the purpose of the lymphatic system? So, immunity is found here in the lymphatic system. Okay, remember I'm an immunologist. This is one of my favorite things. Okay. So we have immunity going on here. What else is going on here? So what's going on is we are picking up, so in the blood vessels, you have these capillary beds. That's where the exchange happens. The blood leaves, you release oxygen, you pick up carbon dioxide, and hopefully you're going to suck up a lot of that extra fluid and send it back to the heart. But it's not 100% efficient, so fluid leaks into your tissues. The lymphatics are going to pick up those extra leaked fluids and send it back to the heart. But along the way, it's going to stop and check it and say, hey, are you okay? Is there anything bad here? If there is, it'll mount an immune response. If not, it'll let it keep going. So all along the way, there are these little lymph nodes. Okay, you guys can feel yours in your neck when you get sick. Sometimes they get really big. Okay, and the reason they get really big is because the fluid that came from maybe your throat or your nose has gotten into that lymph node and said, oh no, something's wrong. And then all those white blood cells will start to divide in order to go off and fight the infection. So as they're dividing, they make the lymph nodes really big. Okay? So immunity is a big thing. It also helps to pick up extra fluid and get it back to the heart. So if you have a messed up lymphatic system, your immune system will be messed up, but also you can get swelling in different areas because the fluid doesn't make it back to the heart to be circulated. Okay? Next is the respiratory system. You've got your lungs, your trachea, which gets the air down into the lungs, your larynx, your pharynx, your nasal cavity. Okay? And what is the purpose of your respiratory system? Oxygen moving like that. Okay? And we're bringing oxygen in, but what gas are we getting out? Yeah. And you guys are going to love when we get to the respiratory system later. It's all about gas pressures and percentages, and it's lovely. It's fun. Okay? So that's the respiratory system. Any questions about those two? Okay. We're almost there, guys. Okay, next two are digestive and urinary systems. Our digestive system covers everything from the mouth to the other end. So anything in that long tube that your food goes through. So you eat it in your mouth, goes down the esophagus, it gets to the stomach. The liver produces digestive juices and digestive enzymes that go into that stomach and help it break things down. Your small intestine, your large intestine, rectum, and anus, all the way out the other end. One long tube inside your body. Okay, what's the purpose of your digestive system? Okay, so break down food so that it can be absorbed. Break down food, absorb nutrients. So it soaks up all the nutrients, send it to the blood, allow the blood to transport it wherever it's supposed to go, and whatever is left over in the digestive system gets excreted. Okay, and then the urinary system. Kidneys, ureter, urinary bladder, urethra. What's the purpose of your urinary system? Eliminate waste. Can't spell. Waste. So the kidneys are going to help filter the waste out of your blood. So they'll pull it out and send it out your pee. That's part of it. Eliminating waste. And we also help regulate something else. Regulate water and electrolytes. Okay. And you guys know this intuitively. When you have too much water, when you've drunk a whole lot of water, what do you have to do? Pee, because you got to get the extra water out, right? There you go. Okay. Any questions for Liberty? All right. Y'all are doing great today. Okay, and our last one is the reproductive system. Got your parts there for the male and female. Luckily, this is the very, very last system that we ever talk about. So it's at the very, very end of AP2 when you all know each other and you're best of friends, and it's okay if we talk about reproductive. Okay, so what is the purpose of the reproductive system? Make babies to reproduce, right? Okay. There you go. Those are all. Okay, any questions? Okay, so just make sure you can match each system with a general function and tell me the organs that are involved. Okay? Good? All right. Now, we have talked about each of these organ systems separately, and we are going to learn them separately in class. We're going to start with the integument system. We'll spend some time talking about that one. Then we'll move on to bones, and then we'll move on to muscles, and we'll work our way through each of the systems. And it'll seem like they all exist on their own as a nice, sweet little system. But I want you to remember, I'm going to tell you this now, and I will keep reminding you throughout the semester, is that our organ systems work in cooperation with one another. Okay, what does this mean for you? This means that although our tests are not cumulative, okay, once you finish the integumentary system, you finish the integumentary system, you're not going to see integument on the next test. But if something that we talked about in another chapter relates back to what we're talking about this chapter, you may be required to know it still. Okay? So don't forget what we talked about. Okay? There's also a cumulative final at the very, very end. Okay? So they come from your old test questions. We'll talk more about that later. Okay? For example, the digestive system. You eat the food. It's broken down. You get your nutrients. But what is responsible for transporting nutrients throughout the body? The blood vessels, right? So there are going to be a lot of blood vessels associated with the gut. So there's blood vessels around the stomach, around the intestines, and they will pick up the nutrients that you take. And then it's the blood vessel's job to transport it from one place to another. So it'll get to your other cells, and they'll help keep your other organs alive and healthy. We also talked about gas exchange. So oxygen comes in and goes out through the respiratory system, but then what transports those gases throughout the body? Circulatory system, right? So the circulatory system is really the road that's going to connect a lot of our other systems together. Okay? But they're all connected, they all work together in different organ systems to make up you, an organism. All right? Okay. Now, these are necessary life functions. Things that you have to do in order to be considered alive, in order to stay alive, if you will. You'll probably see these as a multiple choice question on a test that's either which of the following is not a necessary life function, which of the following is a necessary life function, something like that. Okay? So these are things that you have to do to stay alive. First of all, you must maintain boundaries. Okay? Which one of our hierarchical levels of organization do we consider the smallest living thing? The cell. What surrounds a cell to keep it separated from what's outside of it? A plasma membrane or a cell wall through a plant or a fungus, right? Okay, so we have boundaries around even our smallest living things. So we have to keep what's inside, inside. We have to keep what's outside, outside. And we have to be able to decide what comes in and what goes out. So we see that on a cell. You'll see that in tissues. Tissues will have layers that wrap around them. You'll see them in organs. You'll see them in organ systems. And you as an organism have the integumentary system that covers the outside of you and keep you separated from the outside. Okay, second life function is movement. You have to be able to move. Okay, this doesn't just mean moving around like this. Okay, that movement is important for interacting with your environment. So you pick things up, so you can walk, interact with others. But where else is movement happening? Right now. Okay, where at inside of you? Your heart is moving, right? Hopefully. Hopefully your hearts are beating and are beating nice and strongly, and you are still awake right now, right? Okay, so there's movement in your heart. Where else is there movement? Okay, your eyes. Your eyes are moving around, so you can follow me, you can follow the screen, you can look at the people beside you. Okay, so that eye movement is happening right now. What else? Your lungs are going in and out. I heard somebody say digestion. Did y'all just eat lunch? Hopefully you've eaten lunch and you're about super hungry right now. But inside the digestive system, okay, guys, in your stomach, when food gets to your stomach, not only are there digestive enzymes that are there breaking things down, but there's muscle contractions that squeeze and throw your food up against the wall of your stomach to help break it down into smaller pieces. Okay? So if you've just eaten, you have a lot of movement going on inside of you right now. Okay? And there's movement all over the place. Those little white blood cells, they're moving around using their little hands, looking for things to grab up and kill and destroy. Okay, so you have to move to survive. Responsiveness, what does that one mean? Yeah, you have to change and respond to your surroundings. So we're going to talk about that a bit when we talk about homeostasis. But you recognize what's going on around you, and you respond to it. You change and adapt. So if it gets cold in here, what are going to be some of your physiological responses? You're going to shiver. You're going to get goosebumps. Okay, so those are all going to be things that your body is doing to respond to the environment. happens on the big level, like with temperature, but it can also happen on smaller levels, individual cells in your body that are responding to the environment. Okay, digestion, we've already kind of talked about that. You're taking your food and you're breaking it down into smaller pieces. Metabolism. Okay? Metabolism is the sum of all the chemical reactions in your body. So basically, it's taking those nutrients that you've broken down in digestion and changing them into something useful. You're changing them into energy. Then you may store the energy away as something else, but then you have to get it back out of storage in order to use it again. Okay? So metabolism is all chemical reactions in your body. Okay? Excretion. Get rid of what you don't need. Reproduction. Make more. And then growth. Okay, so there's a difference between reproduction and growth. Reproduction is making something new. Growth is you start with something small and you make it bigger. Okay? So reproduction happens when it's from an egg. And then growth is going to be what happens from when that sperm and egg meet till you are fully adult form. And so you grow through time. Cells divide, they play together, and you get together. Okay? Any questions about our necessary life? And we'll talk as we go through the organ systems about how they help us do these functions. Okay, so the organ systems are going to be responsible for maintaining these life functions. Okay, survival things. Things that we need to live. Nutrients, oxygen, water, a proper temperature, and a proper atmospheric pressure. The one on there that may be a little odd is your atmospheric pressure. But think about going to a higher altitude. What happens to the oxygen pressure when you go higher? It decreases. There's less oxygen there to breathe. So we will talk about that a lot when we get into the respiratory system. But we have to maintain our right pressure in our lungs in order for us to exchange our gases. All right. Any questions about those? Those are pretty. Okay. Then we will move on. Again, this is just that same lecture outline. Do not write it down. It's just telling you where we've gone. We so far have covered those first two bullets of this chapter, chapter 1. We are getting ready to go into the next 3. The next one we're going to hit is homeostasis. As we are talking about this, I'm going to discuss your homework assignment. Okay, so pay attention. And then the next one is about anatomical position and some anatomy stuff. We'll hit that really quickly. And then the last one is serous membranes, which I believe is part of your lab homework. So here we go. All right, homeostasis. Hopefully this is a term that some of you guys have heard before. But homeostasis is the body's ability to maintain a stable internal environment, even when the outside world is changing. Okay, I'm going to go ahead and put the rest of these up here so that we can chat about it. Okay, this next bullet is not important. It's just to help describe what's going on. But Walter Cannon was an American physiologist. He was one of the first to describe the process of homeostasis, and he called it the wisdom of the body. So homeostasis is really cool. It's your body picking up what's going on around it and helping to change things to make sure the body stays constant. Okay? So it's recognizing that the temperature is too high and cooling it off. Recognizing that the temperature is too low and warming it back up. And that's what we're talking about here in homeostasis. It is a dynamic state of balance or equilibrium. Okay? So I've got a graph to show you later, but you're going to be hovering around that homeostatic set point. So if your temperature says in your body, we should be at what temperature? What is homeostasis for temperature for humans? 98.6 degrees Fahrenheit. What about Celsius? 37. Okay, so it's about 37 degrees Celsius. That is your set point. You're going to go a little bit above it. Once you get too high, your body's going to say, uh-oh, it's too warm, and it'll start doing things to cool off. And we'll go back down, and we may overshoot it a little bit. We go too low. Once it gets too low, your body's going to say, uh-oh, too cold, bring it back up. Okay, so we're going to hover around that set point. It's dynamic. It's constantly changing. You're constantly looking at what's around you and what's going on inside your body. Okay? And this all happens without you consciously thinking about it. Aren't you glad that you don't have to sit there and think about, oh, I'm cold, I need to start shivering? Right? Okay, that would take too much brain power. You wouldn't have any brain power left to do anything else. Okay? And every organ system plays a role. Okay, so all those organ systems we talked about, they're all important in maintaining homeostasis. Okay, so any questions about just the basic what homeostasis is? Maintaining balance in the body. Okay, then let's take a deeper look. Okay, homeostatic control. Homeostatic control functions off of a homeostatic feedback loop. Okay, we're going to first look at just the general terms of the parts of the feedback loop, and then we'll use a specific example. This is what you are drawing for your homework. Okay? You are drawing a teeter-totter. This is half of it. We'll show you a picture in a second with both half of it drawn. But you have to draw first the non-specific, just the parts of the feedback loop on there, and then add in the specific parts for the baroreceptor feedback loop, which is blood pressure. Okay? So if we look at our teeter-totter here at balance, it's going to be whatever our set point is, whatever we want things to come back to. Okay? But things are going to happen that will cause us to be imbalanced. Either we'll get too high over here, we'll get too low over there, and we'll have to shift something to get us back to balance. Okay? So the parts of the feedback loop. First, there is going to be a stimulus. The stimulus is going to produce a change in the variable. The stimulus, something has changed. But then we have to have something that's actually going to detect that change. To say, hey, something is different. Okay? The thing that's going to pick up that change is called the receptor. The stimulus, something has changed. The receptor picks it up. But the receptor isn't very smart. The receptor is just like a thermometer. Okay? It shows the temperature change. The receptor, because he knows he's not very smart, is going to send that information to someone who is smarter. So he's going to send it over here to the control center. It gets sent to the control center on the afferent pathway. Okay? The control center then takes that information and makes a decision. It decides what to do. Once it decides what it's going to do, it needs to send the information to something to do that we want it to do. Okay, so he's going to send information to what's called the effector. And we're going to do a specific example of this in a second. Okay, it sends the information to the effector on the efferent pathway. Now, afferent pathway and efferent pathway, we're going to use the word afferent and efferent a lot when we get to the nervous system. An easy way to define these would be to think about the difference between affect and effect. But I know that a lot of us don't know the difference between affect and effect. I use them interchangeably, and I apologize for that. Okay? But an afferent pathway is going to go towards the control center, which in most instances is the nervous system. It's going to be the brain or spinal cord. In most instances. Not always, but in a lot of instances. Okay? The efferent pathway is always going away from that central point. Okay? So efferent goes away, it exits. The efferent goes away, it exits, and it always goes to cause an effect. And it tells the effector what to do. Okay, the effector will cause some change and will shift the balance. Okay, there's going to be a slide of this. A little bit late. We'll do it on the slide. Okay, any question about these general terms? You've got a stimulus, the receptor picks it up, sends the information through the afferent pathway to the control center sends it through an efferent pathway to the effector, and you get an effect. Questions? Okay. Let's then look at a specific example. Okay, so we're going to, instead of saying stimulus, we're going to use an actual example. And our example is going to be body temperature. Okay, there are two different types of feedback pathways. The majority of the feedback pathways we're going to talk about in class are negative feedback pathways. Okay, negative feedback is our main way the body returns to stable conditions. So whatever change happens, it's going to work to return you back to the set point. Okay? The set point is that normal condition. So for example, let's look at body temperature. Okay, so we said that normal body temperature, our set point in this instance, is 37 degrees Celsius. Okay? If the temperature increases, so now it's 37.5 degrees Celsius, a receptor is going to pick up that temperature change, send information to the control center, and the control center is going to cause changes that will bring us back down to that set point. Okay, so that is negative feedback. We're bringing back to the set point. It works the opposite direction too. So now our temperature is too low. Now it's 36.5. We're below our set point. The control center is going to see that, and it's going to cause things to happen to bring us again back to that set point, but now we're raising the temperature. Okay, but both of those are considered negative feedback because we're returning back to what's normal. Okay, so negative feedback returning back to what's normal. Okay. In the instance of body temperature, if it gets too hot, what are some things your body's going to do? Sweat. Okay, so we have a receptor here that picks up, hey, I'm getting too hot. Sends the information to a control center, which is part of your brain, which we're going to get to on the next slide. The brain says, I need to start sweating. So it sends information to your sweat glands, which are the effectors in this situation. They will start sweating, bring the temperature back down. Okay, so sweating begins to cool you off. Okay, from this picture, do you see something else that happens when your body temperature increases? We're up here, we start this process. Vasodilation. Anybody know what that means? Is that what it is? Blood vessels expand. Right, blood vessels expand. So our blood vessels, our arteries, primarily arteries, that go out to our extremities can dilate, can get bigger, and can constrict, get smaller. If you are hot, you're going to want to dilate those blood vessels, get the blood to the surface, close to the skin, so that you can release heat and lose heat. Okay, so vasodilation happens if you're hot. Once the vasodilation kicks in, the sweating kicks in, it's going to bring your temperature back down, back to that set point. Okay, if you get too cold, if we go this direction, now we're going to cause vasoconstriction. In vasoconstriction, the blood vessels constrict. So out in your extremities and your arms and legs and close to your surface of your skin, those blood vessels get cut off. And the blood stays more in your pores. So it keeps that heat in closer to your important organs. And you don't lose the heat to the outside environment. Okay? So you have vasoconstriction. You also start shivering. Once those two things start happening, you'll bring back to that set point. Okay, so it's all about getting you back to that set point that you want to be at. Okay? See that it's dynamic, you go below, then you go back up, then you go below, then you go back up. All hovering there around set point. Okay? Questions? Okay. Now we're going to put it all together. Okay. So I said that for your homework, you're going to draw a teeter-totter. What I showed you before was the top half of the teeter-totter, okay, where you have a stimulus, a receptor, a control center, an effector, and a response. For your homework, you have to draw both sides of the teeter-totter. Okay, so this shows what happens when temperature rises. A receptor, the temperature-sensitive cells in the skin and brain, realize it's too hot. They send information on the afferent pathway to the control center, which is the thermoregulatory center in the brain, specifically for this pathway. It says, oh no, I'm too hot. I need to change this. So it sends information on the afferent pathway to the effectors, or the sweat glands, and you start sweating. The evaporation of the sweat causes the temperature to fall. Okay? Then on the other side, if your body temperature falls, same receptors, those temperature-sensitive cells in the skin and brain, are going to say, you've got a change in temperature. It'll send that information on the afferent pathway to the control center, the thermoregulatory center in the brain. Then it goes on the efferent pathway to the effectors, which this time are skeletal muscles, and those muscles are going to start shaking. It's going to cause shivering, which will increase the body temperature. Okay? So what you are doing is you are drawing this picture with the general terms. The stimulus, receptor, afferent pathway, control center, efferent pathway, effector, response on both sides. Then, instead of this saying body temperature rises, you're going to say blood pressure rises. Okay? Then what happens? What's the receptor for increased blood pressure? You're going to put that beside receptor. What's the control center for the blood pressure pathway? You're going to put that by control center. Okay? So you need both the general terms, the terms that are the same for everything, receptor, control center, effector, all that. And then also the specific term for the baroreceptor pathway. On the homework, we've given you a list. Okay? So you're taking the list and you're plugging them in where they go. Okay? Questions? All right, awesome. Okay. So that was negative feedback. It brings you back to the set point. Positive feedback, however, is going to bring you even farther away from the set point. So something starts, and then in a positive feedback mechanism, it's like a snowball. It keeps gathering speed and getting faster and faster and faster until you have to affect them all. Now, this doesn't happen in as many instances as you see negative feedback. But a couple of examples. Blood clotting. Okay? So you get an injury. You break or tear your blood vessel wall. A positive feedback cycle is initiated. You start forming some platelets that adhere to the site and start clotting it up. Those platelets, once they join with each other, they start releasing more clotting factor. That clotting factor tells more platelets to come and join in on the party. Once those platelets join in on the party, they release even more clotting factor, which causes even more platelets in. See where we're going here? Start with a little bit of platelets, but eventually we're going to get a whole lot of platelets until we get a nice plug form. Okay, so that's positive feedback. You start something and you keep it going. Any other examples of positive feedback you guys know about? Labor. Okay, so this one's cool. So labor starts, you get contraction. When you get a contraction, that baby's head starts moving closer to the cervix, closer to the bottom. When that baby's head pushes on the cervix, it causes hormones to be released that go back and cause more contractions. So the more contractions you have, the more pushing you have, the more hormones released, the more contractions, the more pushing, the more hormones. So it keeps the process going long enough to deliver a baby. So positive feedback brings it farther away from the set point. Okay, any questions? I got like 2 minutes, 1 minute, something like that. Guys, I'm behind the clock. That's okay. Anatomical position, really quickly. Let's see what we can do. Okay, you're erect, feet slightly apart, palms facing forward and thumbs away. Okay, this gives us a place to start as we look at directional terms, as we look at how things are related to other things in the body. Okay, so just make sure you know anatomical position. Okay, so once we get you in anatomic position, then we can say, well, how is something related to something else? So we have directional terms. Okay, we have, I'm going to slide to the side. Well, it's hard to see now. Okay, superior versus inferior. Superior is up, inferior is down. Anterior and posterior. Anterior is to the front, posterior is to the back. You also may see when we're talking about the nervous system, anterior referred to as ventral and posterior referred to as dorsal. Okay, so they're not completely interchangeable, but you'll see them in both places. Okay, medial and lateral. Medial is closer to the midplane, the middle of your body. Lateral is farther apart. Proximal and distal, these are used on the limbs, only on the limbs. So distal is farther away, proximal is closer to the trunk. Okay, so my big toe is distal to my knee. Okay, so distal is farther away, a little distant, proximal is closer. Superficial and deep, superficial is closer to the surface of your body, deep is deeper inside. Okay, so your skin is superficial, your heart is deep. Okay, and those are all that are on our list. So I have to stop because it is time to stop. Okay, but we will pick up there on Monday. Make sure you do your Chapter 2 objectives and that you are ready for a quiz. See you guys later. And guys, make sure you email me.